I love his astronomy. I absolutely love it, and they use it at Rhodes College as well. So I'm going to let you get started. He's going to give us a tour, a VIP tour, that if you were a donor and your name is not on there, it's going to be on our website by tomorrow under Friends of Physics. I just haven't gotten that much. Okay.
Well, thank you all for making this happen here. And so we're going to do a little tour, and I'll kind of give you my standard tour spiel as we go along, but feel free to interrupt with questions at any time. But so we're starting right now here. This is the entrance plaque, and you'll see a similar one but with different content on the other end. And that's because since it's just an outdoor exhibit, you never know where people are going to, well, first of all, a lot of people don't even do the whole tour, right? They just come across something. But for people who do the tour, you don't know which end they're going to start from. So you want to make sure you've got something to introduce them on both sides. So on this side, this is the more logical place to start. So we're introducing the solar system here with the orbits shown out to scale. But of course, the dots in here are way, way, way too big compared to the orbits, which is why we have this model. And in fact, one of the things that got me working on scale model solar systems to begin with, as I was teaching elementary school kids, and we get all this great stuff from NASA, like these montages from Voyage of the moons. And the kids would look at these montages of the moons and they would think, wow, they're really close together. and so it was trying to explain that no, they're not really that close together. There's a reason we call it space. And so we want to get a sense of what space is really like, planets and empty space there. And I'll give you kind of the punchline because it's here. It's right there. I saw it somewhere. Right here. And we'll talk more about it on the other end, but you can see right off the bat, there's our sun, you can see Mercury, Venus, Earth, Mars, and one of the first questions that comes to people's minds is, how far to Alpha Centauri? So how far is it to Alpha Centauri?
4 light years.
And so the scale is 1 to 10 billion. For those of you who have some astronomical knowledge, which I know a lot of you is, the reason we chose that scale is there's only a small range of scales that are both walkable and the planets visible. And within that small range of scales, 1 to 10 billion is the only one that's all zeros except for the first digit, right? Except for the one there. It's just power of 10. It's the only power of 10. So it makes the math very easy. And if you're like me and you know off the top of your head that a light year is 9.46 times 10 to the 12th kilometers, up to 10 to the 13th, close enough, right? Then on a scale of 1 to 10 billion, a light year is 1,000 kilometers. So it's 4,000 kilometers to Alpha Centauri. So equivalent to the distance across the United States. From here to, I don't know, Calgary maybe. And so, you really, a couple things to think about is just how incredibly far that is, but also to realize that we have technology that can essentially be out 4,000 kilometers away from here and see these little dots, or at least detect that they exist, which is kind of mind-boggling. And part of the main point, I think, of this whole exhibit is to get 2 real big lessons across. Number one, we're not the center of the universe. And number 2, but we have really powerful brains when we use them to try to learn and understand and do good